This is the sixth video in Unit 6, and we're going to talk about the graphs of tangent and cotangent, and then I'm going to do another name that graph, and we'll do some problems where you have to find all solutions in radians, and we'll do both with some special angles, but then also when you need to use your calculator. Okay. So let's start with looking at the graph of tangent of x. And in worksheet 6.5, we walk through this by replacing tangent of x with the quotient identity, sine over cosine. And this helps us see where tangent's going to be undefined, where the denominator is going to equal 0, and we'll have our asymptotes. And it's going to equal 0 where cosine is 0. And so tangent's going to be undefined where cosine is 0 or every pi over 2 plus k pi. So when we talk about the domain here, we're going to say all reals except every pi over 2 plus k pi. So let's put in our asymptotes then. And then we'll start thinking about what the rest of the graph looks like. So I've got an asymptote at pi over 2, and then pi away. Well, what am I doing? So pi away, this is 3 pi over 2, sorry. And then another pi away. So 5 pi over 2, and so on. And let's do it on the other side, negative pi over 2. Negative 3 pi over 2. I probably don't need to do this much, but negative 5 pi over 2. Okay, so we've got our asymptotes. Again, undefined every pi over 2 plus k pi. And let's see what's happening in between. So let's take 0, for instance. If I think about tangent of 0, well, sine of 0 is 0 and cosine of 0 is 1. So tangent of 0 will be 0. Let's look at the angle between, because tangent is opposite over adjacent, or y over x, we can think, or when we talk about a triangle, think about the two legs of the triangle. Let's look at pi over 4. So in the 45, 45, 90 triangle, the legs will be the same. So tangent of pi over 4, as we know from the fifth unit, tangent of pi over, or the first unit of trig rather, tangent of pi over 4 is 1. And as I get close to pi over 2, when cosine goes from 1 to 0 and sine goes from 0 to 1, we're going to get that explosive behavior going towards positive infinity. Whereas when I go towards negative pi over 2, when cosine's positive, but sine is negative, we're going to go towards negative infinity. And I could have plotted here, I could have plotted negative pi over 4, and tangent of negative pi over 4, instead of being up at 1, will be at negative 1. And so notice then that, and then after pi over 2, if we continue like this, after pi over 2, let's do some more angles. Just to convince you of the pattern here, let's look at 3 pi over 4, and let's also look at pi. Let's look at 5 pi over 4, and then we've got our asymptote at 3 pi over 2. Well, 3 pi over 4, tangent of that is negative 1. Tangent of pi is 0. Tangent of 5 pi over 4 in quadrant 3 will be 1. And so this pattern is continuing. So notice that it repeats itself, and all the other trig functions that we've done repeat itself every 2 pi. The period of tangent, though, it repeats itself every pi. So that is a change. So the period is pi. And notice if I want to get a single period, I'm not doing the quadrantal angles this time. I can think of plotting, sure, the quadrantal angles, but also thinking about plotting pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, and so on. Okay, so the period of pi, the range is all reals. And a similar is going to happen with cotangent. So with cotangent, if I want to do that graph here, so let me just make a little line. So y equals cotangent of x, and remember it's the reciprocal of tangent, or cosine over sine. So the asymptotes here will be where sine is 0. So the domain in this case is all reals except every k pi. And the range is also going to be all reals, just like tangent. All right, so let's start drawing our asymptotes here. And we've got, so there's an asymptote at 0. And then there's going to be at pi, 2 pi, negative pi, negative 2 pi. All right, and so remember before we plotted those pi over 4, pi over 2, 3 pi over 4? Well, let's do that here. I've got pi over 4, pi over 2, 3 pi over 4. Okay, so at pi over 4, same with tangent, it's going to be up at 1. Cotangent of pi over 2 is 0. Cotangent 3 pi over 4, like tangent, is negative 1. So here's our 1 period, what that graph looks like. So similar, and we're going to talk about shortly how you can, the graphs relate to each other, or how one is, the tangent is just a transformation of cotangent, and vice versa. And if I want to extend this, we can plot, let's say 3 pi over 4, 3 pi over 2, 5 pi over 4. I'm just going to draw one more period here. Up at 1, negative 1. So there's the cotangent. And so those are the two, again, oh, and the period here, like tangent is pi, repeats itself every pi. All right, so let's just do a graph of one of these. And actually before that, looking at the two graphs, how could we, and this is in one of the worksheets, how could you write tangent as a transformation of the cotangent graph? In other words, if I were to say y equals tangent of x, what does that equal in terms of the cotangent? All right, so to figure this out, let's go to the cotangent graph. And what do we have to do to the cotangent graph? Actually, let me just, to make it easier, draw one more period to the left here. Okay. What do I have to do to the cotangent graph to make it look like the tangent graph? So clearly I've got to do some sort of reflection across the x-axis, and I'm going to have to do some phase shift. And there's more than one way to think about this. One way to think about it is in terms of the phase shift right pi over 2, and reflect over the x-axis, but you can also shift left pi over 2 and reflect over the x-axis. So either way works. So you can say tangent of x is equal to negative, reflect that it's reflecting over the x-axis. And then you could say x plus or minus pi over 2. Again, either way would work there. All right. Okay, so let's do one of these graphs. I'm just going to make something up. So how about let's graph y equals 1 plus 2 tangent 2x minus pi over 2. Let's do something like that. Okay. All right. So the period is, instead of being pi, it's going to be pi over 2. So notice here, with all the other graphs, we did 2 pi divided by the b value. Here we're doing pi, because the standard period for tangent and cotangent is pi, and we're going to divide that by the b value. And then let's figure out, normally if I wanted to graph a period, I'd start at 0 and go to pi. Again, not 2 pi, because we're doing tangent. So I'm going to start at pi over 2 divided by 2, pi over 4, and go to 3 pi over 4. I should say my interval width here is pi over 8. All right, so thinking about this tangent here. So I've got pi over 4, which is 2 pi over 8, so 3 pi over 8, 4 pi over 8, which is pi over 2, 5 pi over 8, 6 pi over 8, which is 3 pi over 4. And if we think of tangent, well, when I plug in pi over 4, I should be getting 0. So tangent of 0 is 0. When I plug in 3 pi over 8, I should be getting pi over 4, which is 1. When I plug in pi over 2, I should be getting pi over 2, which is undefined. When I plug in 5 pi over 8, I should be getting 3 pi over 4, which is -1. And when I plug in 3 pi over 4, I get pi, which is 0. Multiplying those values by 2. So 0, 2, undefined, -2, 0, and adding 1. So 1, 3, undefined, -1, 1. All right, so let's just graph 1 or 2 periods here. So the interval width, remember, was pi over 8. So if I'm first plotting pi over 4, I'm going to go to the left of that. So it'd be pi over 8, then 0, -pi over 8. Then I'd have pi over 4, 3 pi over 8, pi over 2, 5 pi over 8, and 3 pi over 4. And I've got this vertical shift up 1. All right, so let's graph my asymptote is at pi over 2 here. At pi over 4, I'm at my, this new kind of, it's since been shifted up 1, it's on that vertical shift line. 3 pi over 8, I am up at 3. And which means if I'm going to the left here, pi over 8, I should be down at my low of -1. And then I should have my asymptote here. And then we said from my table, 5 pi over 8 is -1, 3 pi over 4, I am up at 1, and it would continue looking like this as I go. Okay, and I could continue to the left too, but you get the idea. So that's how you would do the graph. So in this packet, what packet was it? 6.5 with the graph of tangent and cotangent. Instead of giving you a graph for finding the sine and cosine function that describes it, I give you some information. So let's do, maybe let's do A. So the information I give you is I give you that it's a sine and cosine, can be described by sine and cosine. It has a peak at pi over 6, 4, and a consecutive trough value, so a minimum value, a local minimum at pi over 2, -2. All right, so I think it's helpful to draw this. So I'm saying, and it doesn't have to be overly accurate, but we've got some peak value at, we'll just say pi over 6 and 4. So that's going to be a local max value. And then pi over 2. So pi over 2 is 60 away from pi over 6, which is 30. So we've got at pi over 2, negative 2 here, my low value. Okay, so I'm just going to draw. All right, so we can get a bunch of information from here. What we can get is so from a peak and a consecutive trough, that's half the period. So half the period is, so I should say this is pi over 6, 4. So half the period is pi over 2 minus pi over 6, which is pi over 3. So that means the period here is 2 pi over 3. So my b value in my equation is going to be 2 pi divided by 2 pi over 3, or 3. I can find my amplitude. The amplitude is 4 minus negative 2 over 2, or 3. That means my vertical shift here will be up 1. Okay, so let's draw my new midline in there then. And looking at this, it's pretty easy to find given this, I have this point here, let's find the cosine. It's starting at that high value. So remember, without a phase shift and just the period change, the cosine graph would start here. So it means the phase shift is gonna be right pi over 6. So let's write y equals 3 cosine. 3 cosine, the b value we said was 3, x minus pi over 6. Okay, so for finding the sine, I know what did we say the interval width was here? Or maybe we didn't, because it would be nice to find the point to the left that hits the midline to the left of pi over 6. So the period is 3. So the interval width is the period, the period's 2 pi over 3, sorry, the b value is 3. So the interval width will be 2 pi over 3 divided by 4, or pi over 6, which actually is very helpful. So then, because it means that, I'm gonna need my eraser here, because it means that to the left of pi over 6, 4, it hits the midline at 0. So looks like this. So that is very nice, because it means I can write a sine function without having to do any sort of phase shift. So I could say y equals 3 sine 3x. Okay, say you didn't notice that. Well, you could then have been like, okay, let's find halfway between pi over 6 and pi over 2. Let's find what that point is. Again, say you didn't think to go to the left of pi over 6. Well, if I find that point here, so halfway between pi over 6 and pi over 2, well, that's pi over 3. So I could have talked about a shift to the right pi over 3, but notice if you're going to use that as your phase shift, notice how the sine graph after pi over 3 goes down. So you would have to have a negative in front of the amplitude. So, and you certainly could do that. So you would say y equals, I just forgot something. I'm just realizing that I forgot to put the vertical shift in here. My bad. +1, +1. Sorry about that. And so y equals -3. So -3 sine 3x minus pi over 3. And I'm not going to forget now, +1. Sorry, almost forgot that vertical shift there. Okay,